Mr. Berry here, again with another absolute value function that's going to already be here on the graph for us. And I just want to pinpoint certain locations and start to kind of get to a point where we understand what all that means and be able to at least use a little bit of information here to get it. So I have this absolute value right here. A good starting point, no matter what, from absolute value functions is figuring out where is our vertex. And hopefully we understand a bunch of things using the vertex. We can see right here that dot is the vertex in this problem. If we travel from the origin, we go 1, 2, 3, 4 over to the right and up 2. So that means that the point that is the vertex is the point 4, 2. That's going to be important for a lot of different reasons. The first one we want to check out is just looking at the picture and taking a look at that V. Now we should notice a couple things about that V, but from the vertex, all the points that we have for our absolute value are above the vertex. The vertex is the lowest point on the graph right now. So what that does for me is lets me know two things. The vertex being the lowest point lets me know that it's acting here as a minimum. And if it is a minimum, it's going to really help me understand what our range values will be here in this absolute value function. We can have points above that spot, but we can't have points below that spot. So here for our range, we're going to have a range that is y is greater than or equal to 2. The lowest y value on the graph is at the spot where y is equal to 2. I mean, the point's 4, 2, but the lowest spot here for our y values is the number 2. So we have to be above it if we have other points, like here's 3, y value 4, y value 5, so on and so forth. Much like most of the time here, our domain, if you take a look at where the arrows are located on the graph, involves our negative infinity and our positive infinity. Where we have arrow that goes off to the right forever, arrows that tell us we're going to go off to the left forever. Other information that we get from our vertex. We get the fact that there is a mirror here in this picture that's not drawn in, but we can draw it in ourselves to help out the cause a little bit. And it would be right through the vertex, an imaginary vertical line that will help us see that we're mirrored on either sides of that mirror. That axis of symmetry right there is going through our vertex. And since it's a vertical line, we know that that vertical line would have an equation of x is equal to something. Our vertex is on the point 4, 2, so that means that that axis of symmetry would be the imaginary line x is equal to 4, where no matter where I travel on this, and I kind of stopped here, but it would go through my handwriting, that imaginary vertical line doesn't stop at all, and we have an x value of 4 no matter where I travel on that imaginary line. One last thing I want to point out about this particular graph is we're able to kind of take a look at both sides of that mirror and try to figure out what it is, how are the slopes working for this picture. I want to count from the vertex here, and I'm going to count to the right first. And if I count to the right, I go up 1, and then to the right 3. I rise 1, and I run 3. So here, in this problem, going off to the right, the slope would be 1 over 3. We should know from the previous example that how this works is that on the other side of the mirror, we're going to have a slope that is the opposite number. And in this case, it kind of goes out true that I'm going up 1, but I'm going to the left 3, and that left would make this slope negative. So on the right side of the mirror, we have a positive 1/3 slope. On the left side of the mirror, we have a negative 1/3 slope. It's a lot of information just from one picture, but a lot of that's based on the vertex. As we move forward, we'll have more information and we'll be able to use this information to make an equation. But for now, it's great to be able just to pinpoint our vertex, figure out if it's a maximum or a minimum, get our domain and our range, and we're really focused on the range there because the domain we know we're going to have this an awful lot. Figure out our axis of symmetry, which will help us figure out how are our lines interacting with slope.